Hi guys, in this video we're going to look at the differentiation of the exponential function, otherwise known as e. So if you look at your tables book, what you'll see is we have the general definition where we have the f of x is equal to e of x, then the differential is e to the x, it doesn't change. And if you have the differential of e to the ax where a is a constant, then this differentiates to a e to the ax. So let's have a look at a few examples here. So we've got find dy dx if y is equal to 2x plus 1 brackets e to the x. Okay, so let's rewrite that for a second. We've got y is equal to 2x plus 1 e to the x. Now the first thing we've got to ask ourselves before we do anything is what type of rule we're going to use here. And the first thing hopefully you'll notice is we have 2x plus 1 in a bracket multiplied by e to the x. So what we have here is a product rule. So the first thing we need to do is we need to go to the side, label first one u, the second one v, and go to the side and work out the differentials of u and v. So u is equal to 2x plus 1, which means du dx is equal to 2. V is equal to e to the x, and this is the new one, dv dx is equal to, according to the definition over here, e to the x goes to e to the x. We're now going to throw that through the product rule, and the product rule, if you remember, is dy dx is equal to u dv dx plus v du dx. Now if you're not sure where that comes from, there's videos on the product rule, so just go and check out my other video. Substituting what we have, so we've got u, which is 2x plus 1, we have dv dx, which is e to the x, okay, and then plus v, which is e to the x, and du dx, which is 2, and I'm just going to stick it in front because it doesn't matter if I stick it in front or behind, it's multiplication. So, u, 2x plus 1, dv dx is here, which is e to the x, plus v is e to the x, du to the x is equal to 2 there, and that's what we have. Now what we can do here is, if we want to, we can simplify this slightly. You can see that we have e to the x in both of these terms. So I have e to the x in this term, e to the x in this term, so I can factor it out. So I get e to the x, and now I get 2x plus 1 from this term here, and then I'm going to have plus 2 from this term here. So just double check that. E to the x by 2x plus 1 gives me 2x plus 1 e to the x here, and e to the x times positive 2 gives me plus 2 e to the x. You can tidy up the bracket now. Get e to the x, 2 to the x plus 1 plus 2 is just 2x plus 3. So we've got 2x plus 3. And we generally put the 2x plus 3 in front of the e to the x, but it makes no difference. So 2x plus 3 e to the x, and that's our dy dx. Okay, let's have a look at another example. So in this example we have the chain rule, and in order to do the chain rule, what we do is we differentiate just as we did before, leaving whatever's on top. So e to the x squared plus sine x here will differentiate to e to the x squared plus sine x, but then what we have to do is we differentiate whatever's on top. Okay, that's all this is saying. So let's have a look at this one. So I'll do a couple of these examples with you. So we've got y is equal to e to the x squared plus sine x. So dy dx, okay, all we do is we rewrite whatever the e to the power of whatever it is. In this case it's e to the x squared plus sine x. That's the first thing we do. So we write down e to the x squared plus sine x, do a bracket, and all we do then is we differentiate whatever is on top of the e. So here you can see this is x squared plus sine x. X squared differentiates to 2x, and plus sine x goes to cos x. And then we can either leave it like that, or we can change the order around. That's absolutely perfect there. Sorry, I was missing x there. Okay, let's have a look at another one. So y is equal to e to the x squared plus 2. Same sort of idea. Dy dx is equal to, rewrite the whole thing, e to the x squared plus 2. Have a look on the top, differentiate that, and you'll get x squared goes to 2x. We'll stick it in front here. So we now have 2x e to the x squared plus 2. Remember that 2 here will differentiate to 0 because it's a constant.